Goldratt Research Lab is focused on helping organizations make better, faster decisions. Well, there are some environments where that objective is really, really difficult to achieve. If you think of any environment that has any form of VUCA, volatility, uncertainty, complexity, constraints, ambiguity, being able to predict the impact of changes or understanding how sensitive an environment is to some changes is a really difficult problem to solve. In fact, going back in 1970, a famous scientist, John Conway, created a little board game called The Game of Life. You can still download it on the App Store if you want to play with it. And what he tried to see was, if you observe very simple behavior, does that mean that it comes from very simple rules? And when you see very complex behavior, does it come from very complex rules? The game was very simple. So imagine a checkered board, and each cell on that checkered board represented an organism that was either alive or dead. So if you imagine one of the little cells, around it there was 8 other organisms. And the rules were very simple. If you had less than 2 organisms, other live organisms touching you, you would die of loneliness. If you had more than 4, you would die of starvation because there were too many to consume the parts. And what the game was is to play it iteration by iteration. So at the end of every round to decide whether each cell on the board was alive or dead. And people speculated what was the outcome that you would expect. They assumed that because the rules were so simple, that the outcomes would be very simple. Everything would be dead, or you'd get some kind of very simple pattern. Just by the rules, everything couldn't end up being alive. And to their shock, they observed the most incredibly complex patterns from this, coming from these very simple rules. And they realized that there was no way to go backwards from these complex patterns back to these simple rules. And this challenged one of the most fundamental issues within mathematics, is that we always thought that when a system is deterministic, which means that we know the rules, that it also made it predictable. That when you press the play button, because we know the rules, you can accurately predict what will happen. It turns out that this game of life proved that very small changes can have a dramatic impact on the outcome, which makes it unpredictable. Now, most organizations today fall within this category. They are organizations that are essentially on the edge of chaos. There's so much volatility, uncertainty, complexity, constraints, and ambiguity that you simply cannot predict with normal traditional methods, static calculations, using an Excel spreadsheet to determine, what the outcome will be of a small change. In fact, the only technology that can answer those fundamental questions about, if I made a change to my company, to the rules I use, or there's some external change, what will be the likely output? The only technology to answer that question is simulation models. Similar to what the game of life was. Today, what we have found, because of the incredible explosion in simulation modeling, we can very quickly build an accurate enough model of not just a part of a company or a whole company, but a whole supply chain. Accurate enough to be able to predict what likely will be the impact, because in many environments, big changes can have a very small outcome in terms of results. At the same time, a very small change in the right area can have a very big impact on the bottom line of that organization. And that's the reason why we work with our customers to develop simulation models, because basically it's the only technology that can answer those fundamental questions about how much better we can do, what's the simplest, fastest, lowest cost, lowest risk way of doing it, and being able to do sensitivity analysis and scenario comparisons.